Hello, my name is Henriquez, and today I'm going to be presenting my Lab 1 of Physics 2111 about constant velocity based on Newton's second law. This lab is based on applying the principles of Newton's second law in a real-world scenario. For this, I recorded an object moving in a straight line on what is assumed to be constant velocity, and I used Tracker to record the motion. Then, I used GlowScript to model out the predicted motion of my object. Finally, the main goal of this experiment is to compare both the object's motion recorded in the video with the predicted motion of the computer model made by GlowScript. So the main theory behind this lab is Newton's second law, which states that the acceleration of an object is directly dependent upon the net force acting upon the object and the mass of the object itself. With this, we have the formula that states that F net is equal to the mass of the object times the acceleration of the object. And for the code, the two main formulas we used was the position update formula right here. This is the formula, and this is how we presented it in code. And the velocity update formula, this is a formula, and this is how we presented it in code. The conditions, and for the purposes of this experiment, we're not considering the force of friction or air resistance, and we're assuming that the object is moving and will continue to move at a constant velocity. Now we'll see the main unedited video I used to record this lab, which is right here. In this video, we can see that the object, which is an eraser, is moving to the right in a straight line at a constant velocity that we assume. And the forces that are acting upon this object, the eraser, would be the force of gravity, the normal force, the applied force that is moving the object to the right, that was the applied force I applied at the beginning, and friction and air resistance, which are two forces we're not considering for the purposes of this experiment. So to edit this video, we used Tracker, in which we had to establish a y-axis and an x-axis for our movement, and we had to point out the point of mass of the object at each instant of its trajectory, and then Tracker modeled out the motion of the object, the average motion. So here's how it worked. Here we can see how the object is moving to the right at what is assumed to be constant velocity. And right here is a graph that we have of this constant velocity that we achieved in this motion. On the other hand, we have our computational model we used using GlowScript. Here is the main part of our code, which is the while t is less than the total time, which is 3.166, which was the total time of our movement recorded. We assumed that the net force was equal to 0. We have the two main formulas we explained earlier for the theory of our lab. And then once we ran this code using the measurements of our object, we had that the position versus time would be a straight line. And here is modeled out the motion, the projected motion of our object. We then pasted both the observed model values and the predicted model values into a chart in Excel. And then we constructed this graph, which shows the predicted motion going in a straight line throughout the whole 3 seconds, and the observed motion, which is very similar at the beginning, and then it's slightly lower towards the end. So in general, we saw that the observed motion and the predicted motion were very similar until the end of the motion. And this change at the end was probably because the object in the observed motion was slowing down due to friction and air resistance that the computer model doesn't account for, as it's considered to be constant velocity. Given both models, we can see that the object did move in a straight line and almost constant velocity until the force of friction and air resistance started to slow down the object at the end of the motion. Now to finish off the lab, I'm going to present two hypothetical situations. The first one is what would happen if F net was equal to 1000, and if this were the case, the object would have a positive acceleration and the motion of the object would look like this curve. Here we can see a curve rather than a straight line,
because the object is no longer moving at constant velocity, but accelerating each time. Now the final hypothetical situation would be, what if I changed x to negative x? And in this case, the object would no longer be moving towards a positive number, but instead towards a negative number. And because of this, in the graph shown by tracker is downward sloping, so it's moving towards negative x. Thank you, and I hope you learned a lot and enjoyed this lab.